screen. Okay, let's start. Kinematics revision. Okay, I'm doing the revision based on the idea that you are not sleeping in class, that you know something about it. So obviously you need to know the definitions. Definition of what? Acceleration, speed, velocity, right? So that is very straightforward by itself, memorize. Then of course the formula, you definitely will have to use it. A equals V minus U over T. And know how to use it properly, right? And then when A is negative, it doesn't mean opposite direction. It means deceleration. It means deceleration, correct. Okay, so basically applying the formula should not be a problem. Okay, then after the next level will come the graph. Okay, the first set of graphs, speed time graph, velocity time graph, okay, are roughly somewhat straightforward, right? So as with all the graphs, we remember the gradient must give us acceleration, right? And that if you want to find the distance, is the area under the graph, right? So just being very careful, and you will know the how to find the distance. Sometimes it's a trapezium, sometimes it's a triangle, and so on. Okay, so what's the difference between speed time and velocity time? Well, one has direction and one doesn't have, right? Okay, then the next type of graph becomes more difficult and confusing. So you get distance time graph. Jeremiah, what is the gradient for distance time graph? Speed, yeah, good. Okay, so you always must bear in mind this one gives you speed. Then displacement time graph gives you velocity, yeah. Okay, so all this is there, but as you say, right, applying is not always so straightforward. Okay, so reading off the graph, ask you calculate acceleration, ask you calculate distance, should be okay unless you're careless. And then of course, the conversion from one graph to another, that is the confusing one, right? For example, speed time graph to distance time graph. Yes, something can be confusing, or distance time graph to speed time graph. All this can be very confusing, okay? But later we talk about that. Okay, to me, the most important and the one which usually you stumble upon in this kinematics chapter is when you have objects thrown up and down. I revised with you this many times already. Yeah, so the facts are, you must get the facts right. Okay, because like today, the facts, Ikasia on the other day could get, I would say, all the facts right, but then applying it, it didn't seem so obvious really. But basic level, you must get the facts right. Okay, so object going up, object coming down. So the first one we talk about speed being the most obvious. Speed on the way up. Increase?
Wait, no, it's decreasing.
Decreasing. Yeah. And then speed on the way down?
Increase.
Yes, this is the most obvious. And at the top, speed is? Zero. Okay, so usually speed very commonsensical. And the one which I must write in red next is because this is the one that gives the most problem, and you have to always be very careful about it. Acceleration on the way up. On the way up. 10? Minus 10? 10 or minus 10?
Wait, no. No, it shouldn't be increasing. It shouldn't be anything positive for it. Slowing down, isn't it?
So is 10 or minus 10?
Minus
10.
Because it's slowing down.
Because it's slowing down, it decelerating. So you apply some common logic, it's slowing down, so it should be a minus. Okay, good. And what do I call this constant, decreasing or increasing? Constant. Careful, it's constant. You know, a lot of people are going to say decreasing because they're thinking of speed. But acceleration is constant, minus 10. And then when it's on the way down, obviously Peng Hong, acceleration now becomes 10. And this is also constant. Yeah. Okay, then at the top, right at the top, this one is the danger one. 10. What will everybody else say?
0.
And you guys also probably say 0, right?
Probably say 0.
Right, okay, so remember, especially this one, cannot emphasize enough. At the top, at the top here, acceleration is 10, right at the top. Why? Why is it 0? I thought you say speed 0, acceleration must be 0. The reason is because there's only one force acting on this object all the time, and the name of the force is? Gravity. And gravity, no matter what, gives you acceleration of 10 on Earth. Okay, it can be minus 10, it can be 10. We are talking about moon, okay, then it'll be 1.6, right? So these are the facts you must always bear in mind when you are going to talk about objects thrown up and coming back down, okay? These are the facts that you must have in mind. Okay, then to apply it comes another, that one requires practice. So it's always very useful to remember the shape of the graph, okay, for object thrown up and come down. Even you cannot remember with the facts, you can figure it out in case you forget, but useful to remember in that sense. Speed time graph, up, down. Straight line, you drew a U, he says a V. Which one?
Wait, for this.
Speed time for the ball. Speed time graph.
It starts from top and then goes deep V.
V shape. Good. You know, a lot of people are going to say everybody likes to draw this because that is, in a sense, in your mind, the shape of the trajectory. Okay, but that's not correct. You think there must be an initial speed because no initial speed will go up. So you must start from the top and then after that go to the bottom. Okay, so it has to be a straight line. Why does it have to be a straight line? Because acceleration is constant, right? Okay, so and then of course, if you know this, then you will know that here is at the top, right? Okay, so it's very useful. So in a sense, you just tell yourself V shape, right? If not, just rely on the facts to get your answer out for yourself. Okay, then the next one, velocity time graph. How should it look like? Velocity time graph.
Straight line all the way. Yeah.
Straight line going down?
Yeah.
From here, straight line going down. Yes. Okay. You can also do it very fast conversion from over here to here, right? Remember what I said last time. Once it changes direction, what happens? Just flip. Correct. Okay, so change direction, flip. Right, in that sense. So remember one word, change direction, flip. Yeah. Okay, so you flip it, you get a velocity time graph. Okay, so then other things, don't be too worried. You see here 0, then this is minus 10. So if you ask, is the velocity increasing or decreasing? From this at this portion here, increasing or decreasing? The velocity is increasing. Then why do we have a minus?
Because it's opposite direction.
Because it's opposite direction. Very good. Okay, see, you're everything getting correct now Okay, afterwards let's see when you apply what happens Okay, now, so these two graphs as I say are worth remembering. Okay, let's do a little bit of conversion of graph, which of course normally you hope it doesn't come out okay, because it's not always so easy. So conversion of graph. So you ask, okay, draw the distant time graph of this object going up and down. Of course, you can memorize the shape, but okay, we cannot always remember everything. So if you want to convert speed time to distance time graph, what's the first thing I tell you always remember? What you should do?
Find the distance.
Not yet. I'm more concerned of the shape. Okay.
It's technically a V shape still, but
it's a V shape.
It's not a V.
Okay, remember this is what I told you all to do. Distant time graph you write down there. What's the link between the two? The gradient, right?
Yeah.
So the gradient of a distant time graph gives you speed, right? Okay. So once you write this down, then you separate this into sections, and you ask yourself, this portion here, Jeremiah, speed is?
Decreasing.
Speed is decreasing. So you write here speed is decreasing. Then you see speed is decreasing and gradient is decreasing. That means I'm going to draw a graph which has decreasing gradient. So
it's like that.
It's
no, it's
like
not.
that?
No, it's the other way.
No.
It's like that.
Wait.
Because it's
Okay,
decreasing.
1 Or is it 2?
2.
But then what's decreasing? Increasing, or isn't it?
Increasing is steeper.
No, it's
Decreasing, getting less and less steep.
This one, because
One.
it's getting
It's
less.
one, right?
Is
one.
one.
Never mind.
Okay, so careful. Okay, whatever you do, when you draw, after you draw, it's very easy to make mistake. You ask yourself, okay, is this decreasing or not? So you just check and make sure you have done the right thing. You see, is this decreasing? Ah, yes, it's decreasing. Okay, so you look at this portion, you say decreasing, then you draw a decreasing gradient. Okay, then after that, the next portion, you carry on. The next portion over here, okay, the speed on the second side, or when it's on the way down over here, this part, increasing. So this is increasing means the gradient must be increasing.
So now it's a slope up.
Slope
Slope up.
Slope upwards. Okay, is it like that?
No.
Why is this wrong?
Because
Because
there's no
this
negative
tends to
distance.
decrease.
There's no negative distance. Rather, you should say there's no negative gradient.
Oh yeah, yeah.
All right, and then the distance cannot be
Zero.
Zero.
No, distance cannot be
decreasing, right? No matter what, you can say it's slowing down, but you cannot say the distance is increasing. Even when you are slowing down, also your distance is increasing. So this is not correct, right? Okay, so be careful. Okay, so you see gradient is increasing means I have to draw something like that. And after you draw, as I said, always check what you draw is correct. Is this an increasing gradient? Getting more and more steep? Yes, correct. Good. Okay, so always get the shape out first. Then after you got the shape out, okay, you can go and calculate the values. And the values, you just calculate area on the graph from that side. So get the shape out, then draw the shape, then you add in the values. Okay, so that was the distance line graph. So if your distance time graph is correct, your displacement time graph would be instantly correct. Right? Should be, right? So within 2 seconds you can tell me what's the difference. How different does it look?
Wait, positive and negative is that?
So from here to here, what happens?
Same thing as
Same thing. Then after that,
It goes straight
Go
down.
straight down because it changes direction.
straight You mean a straight line
No, like
Flip the thing, right?
Yeah.
yeah.
Flip the thing, it should look like that right? Okay? Right? So then after you have done, every time you always do you check velocity increasing, gradient increasing. Yes, correct.
Wait, I don't think it's like that.
Shouldn't it be in
Shouldn't it be just go straight down and then because it's going in the opposite direction, so the displacement will turn back to zero, which is
No, because it landed in the same spot where it came from.
Okay.
Like if it's starting from here and
Yeah.
it's at here, so it should still be zero.
So the displacement is zero. Back to the reference point. Let's say you throw the ball and you catch the ball back, right? The total displacement is what?
Zero.
Zero, right, Matthew?
yeah.
So here is I throw, here is I catch back. At this time I catch back. So the displacement is zero.
Yeah, I know displacement. Wait.
Okay.
Wait,
I understand, but it also doesn't.
it doesn't.
Okay.
Wait, so
So we look this part this one was on the way back down. This one is on the up. On the up, this kind of gradient gives you a
Oh, never mind.
velocity is the velocity here is what?
Decrease.
Decreasing. Right? Makes sense, right? You think we throw something up, velocity is decreasing. Yes, it's decreasing, correct. And then this gradient which I just drawn is also decreasing. Right? So up to this point it reaches a certain displacement. Okay, whatever it may be whatever value. That one you can calculate from the area on the graph. Okay? So over here, right at the top here, by the way, the velocity is what?
Zero.
Zero. Right? So here the velocity is zero because at the top, then after it starts to increase again. So it makes sense, right?
Oh,
Okay? So I say okay, you don't really memorize this, you try to figure it out. Okay? And actually the graph, you remember we did this before. The graph can actually extend like that.
because it bounces.
Perhaps this guy he threw from his hand and then after that
You didn't catch it.
he didn't catch it, he let it hit the ground, right? So it will hit the ground at a certain displacement below his hand. So here means it's already beyond the reference point, in the other direction. Okay. So that's a conversion graph. Okay, normally doesn't always come out, but well, who knows, huh? Nothing, right?
No, that's recording.
Recording. It's recording.